Next up, we have a person giving a talk on machine learning in e-commerce. He comes to us from San Francisco and is a partner at Resolve Digital. So please, everybody, give a warm welcome for David Jones.
All right, hey everyone, I'm David Jones from Resolve Digital, and today I want to talk to you about machine learning and e-commerce. But before I get started, you may have noticed that I sound a little bit different to some of you, and that's because I'm from New Zealand. So I thought to get to know each other a little bit better, perhaps I could show you some unique New Zealand things. So here is a picture of New Zealand. Fun fact for you. In 1982, we had 70 million sheep and only 3 million people. And when I tell people this, they think, you know, if you're on your way to work, maybe you've stepped over a few sheep, you get to your desk, you have to clear a sheep off your office chair, and but the reality is that most of the sheep are in rural areas, and you wouldn't really see a sheep on your day-to-day commute. This is Marmite. Has anyone had Marmite before? Oh, a few more than I thought. Okay, excellent. So this is a yeast spread that's unique to New Zealand, and we recently at Rails Camp, just above New York, we actually gave this to some unsuspecting victims, and it was after a bit of drinking, and what we found is that some people sort of said it tasted a little bit cheesy and finished it up, and other people, just the first bite, they just hated it and threw it in the bin. So one thing that we have in common with Canada is the Queen. I think we're all very proud of that, aren't we? Recently, I went to London and I visited Buckingham Palace. And you can see just on the top of Buckingham Palace there, the Union flag was flying. And this actually signifies that the Queen is not in residence at that time, so didn't come too close to the Queen, unfortunately. One other thing we like is rugby. And this is the All Blacks playing against Canada. And we actually ended up winning this particular match 79 to 15. And I'm pretty sure I know why. It's because Canada plays with their eyes shut. So this is my first time in Canada, and really happy to be in Toronto. I thought it was pretty cool that you guys made it onto The Simpsons, and so yeah, I'm definitely going to have to come back. Okay, so let's get to it. So machine learning and e-commerce, you know, like fine wine and cheese, they're better together. And you know, at Resolve Digital, we build and maintain and optimize e-commerce stores, and very rarely do we see people actually using machine learning in practice. So what I wanted to do is sort of talk about this a little bit more, because I know that there can be some great benefits for all of us if we embrace it a little bit more. So these are some of the things that you can do to give you some idea around machine learning and e-commerce, and I'm just going to go through some of these. So you know, recommendations, one of the sort of cornerstones, based on everything I know about you or the data I have about you, what products would I most think that you want to purchase? And this is very useful if you have a lot of products. Bots. Any of you, did you see the F8 conference, the Facebook conference? They were talking about integrating bots into the Facebook platform, and there's been a lot of chat about conversational commerce. And the reality is that most of us don't really know how this is going to work in the future, but it's an important part of machine learning because of the natural language processing required to understand what people are talking about when they're chatting with a bot. Email marketing. You know, there's this one fundamental thing that I keep coming back to, which is sort of why are we sending the same messages to everyone in our email marketing campaigns when each of us have very different individualized needs and desires. And with machine learning, we can treat it as a prediction problem to individualize what we send to each person. And it's really not enough to even segment groups. I feel like there's been a bit of a shift to try and segment lists and that kind of stuff. But really, you need to be doing it completely on an individual basis. Fraud detection. We had a client that had a massive fraud problem, and this, to give you a sort of a mindset of what someone who's committing fraud is like, if you have, say, 100 stolen credit cards, what you do is you want to translate that into cash, right? So you look for items that are small and easily shippable, that have high value and high resale value, so that I can basically go over to your store that doesn't have very good fraud protection. Maybe I go buy that GoPro that's worth $300 or $400. Maybe I buy 10 of them at once, and then I can put that off into the secondhand market because I know that I can get 80% of the value from that, and the shipping is all pretty cheap. And so that's how you commit fraud. So don't do that. So the way that we detect fraud with machine learning is that we take into consideration a lot of different data points about an order, whether it be the address verification. So has the billing address matched the credit card? Because if I had 100 stolen credit cards, it's going to be very difficult to know the addresses of each of those and where they came from, unless you stole that information too. But then also shipping. If I'm maybe I've ordered in the US, but I'm strangely shipping to Canada. That's just might be an odd thing potentially for some businesses. So there are certain hints like that. Another one I've seen that's quite interesting was figuring out how old an email address is. And if you're a fraudster, you're trying to basically generate a lot of new email addresses that have no trace on the internet before then, and try and make each order different. So that's how you can get around that. So machine learning sort of is wrapping up a lot of these different points and trying to figure out sort of how dodgy an order is or not and making a decision. Pricing. Yeah, it was interesting actually earlier about the pricing class and figuring out where you can decide on pricing. So if any of us have used Uber, which I imagine most of you have, then you would have been subjected to dynamic pricing, where Uber is basically making a prediction on demand, and if they predict that the demand is going to go up in a very short space of time, then they're slapping a surge charge on you, which is really annoying. But it keeps the supply and demand level and optimizes the revenue that they can get. And finally, let's talk about abandoned cart emails. I'm pretty sure everyone knows what an abandoned cart email is, but what's important is the timing that you wait in terms of when are you going to actually send that email. And also quite often people put like a little personalized discount with their email, and some people need a little bit of motivation and some people need a lot of motivation. So you can treat that as a prediction kind of task to figure out how much discount you're going to give, and obviously you want to minimize the amount of discount you give and maximize the number of conversions you get off those emails. Okay, so this is obviously Amazon, which is the largest, well, one of the largest online retailers, obviously. And here is their homepage. And I think one thing that we can all kind of agree on is that this particular page has probably been iterated on and tested hundreds, if not thousands of times to get to what we see today. So there's probably a lot to learn about this particular page. So aside from learning that I'm interested in running in coffee, what do you notice about what you see on this page? So this is how I see it. I would take a good guess that probably about 50%, maybe more, of this page has probably come through some sort of machine learning algorithm. And I'm talking about the sets of lists that have chosen to be put in here, the order of those lists, and then the items inside those lists, and also the order of those items too. And even the ads, there's 2 ads on there, and those have probably been chosen because they think that it's going to be the most relevant to me. So this is a really large company that refined this page a lot and is probably making a lot of extra money off this by going through this kind of process. But the thing is that machine learning is not just for the big guys anymore. It wasn't too long ago that you actually needed a team of data scientists to really run all this stuff in production. It's unlike our day-to-day kind of programming. It can be quite complicated, and only big companies used to be able to access this. So this is a little comic that I drew up to sort of explain the barriers to entry. So here we have this very tall, large wall that most of us can't get over, and we have a look over the wall and we see unicorns and amazing things on the other side. And these big companies have a private access store. They have the resources to just be able to pick up this stuff, and they've been getting the gains from this for quite a long time. But the one solution that we can all pick up and utilize today is predictive APIs. So it's kind of like the ladder in the situation, where we're able to encapsulate a lot of the complexities of machine learning and treat it as sort of an API problem that you can integrate with and know that the complexities are handled for you through the API. So predictive APIs are essentially our secret weapon to machine learning. But I'm pretty sure that it doesn't run on a floppy disk, it runs in the cloud. Okay, so let's just go into what is machine learning and how does it work. So in 1959, Arthur Samuel defined machine learning as the ability, the field of study that gives computers the ability to learn without being explicitly programmed. So the key there is the explicitly programmed part. So I'm going to go into that in a little more detail so that we can all understand exactly what explicit programming is and then how not to do that. So here's a little bit of like semi-pseudo code on some way that you might solve a particular problem. So if I asked you, based on when looking at a certain product, show me 3 related products to that product. And you might say, okay, let's say the example is we're looking at a fedora. And fedora is a type of hat, so you'd expect that the category on this product would be a hat. And I might just assume that, okay, if you're looking at a fedora, you're probably interested in like the top selling hats in the store. So let's just go ahead for our related products. We're just going to look at the category, grab the top selling hats, and return that. And we put this live, and then we realize actually that now every time we're viewing a hat in the store, we're always showing the same three products all the time, and that's kind of lame, and it's also going to make those particular products get even more popular because they're being shown a lot more. So you say, okay, no problem, we can re-architect this a little bit, and let's do the same thing, but we're going to take double the amount that we're looking for, and then just randomly grab out the amount that we want from that. So we could grab 6 top sellers and then just grab 3 from that. And we put that live, and then you realize actually, no, there's also sometimes you also want to recommend a tie with the hat. And so now we're always recommending the top selling hats. And so you want to evolve this a little bit more, and you say, no problem, we can have many categories now, and we're going to go through all of those and then grab 6 of each of those, and then finally grab a final 3 out of that. And that's the good thing about this is that at least it's increasing the serendipity of the results. But it still has some limits. And now when we put this live, we realize actually that there's actually a specific tie that goes with this fedora. So we were going to introduce hand-picked related products now. Very, very fancy. And because we're looking for 3 related products, now we're going to maybe we've only got one hand-picked one, so we have to then go backfill the other 2 that we're looking for. So we're going through there, and this code is really not the point. My point is that what we're doing here is we're basically observing new customer behavior, then going back and writing more explicit rules, and then just repeating this process. And you're never going to be done. You're going to be constantly theorizing about, what new thing we should incorporate into this now to make it better. And so that is explicit programming. And what it gives you is immense code base complexity, an ever-increasing amount of complexity, and you do not want to be him. So coming back to the definition again, we're trying to avoid explicit programming. So really, in order to fully grasp this, you have to completely shift your thinking away from what I just showed you. So let's just take an example here where on the left-hand side, you've sort of got traditional e-commerce where someone maybe every 5 months is sitting down and trying to decide all the new prices for their products. And so, what should we sell the product price for? Well, you take costs and we'll add 50%, and that's $12.78. And, I'm in a good mood today, and 9 is my favorite number after all. So let's just make it $9.99. Somewhat arbitrary, but slightly based on some science, perhaps. Whereas the mind shift is required in order to really understand how this could be automated. So instead of every 5 months, we're looking at every 5 minutes now, and based on everything we know about all of the past history, and a stock level of 31 right now, and 230 people have viewed it in the last 24 hours, that we predict that $14.32 will optimize sales. So we've flipped the equation, and now it's become a prediction problem. And some companies, they base their entire business off this as a point of differentiation. So take a wine club, for example. Here is Club W, which is basically building their entire business based off the fact that you have a palate profile, and that you're going to give feedback on which wines you like and dislike, and it's going to try and match you completely based off data. And to be honest, I would trust way more a service like this that I knew was listening to that data and responding to it and learning from it than someone else who might not have this sort of involvement and maybe is just selling you something that they happen to have a lot of in stock, or they got cheap that week, or whatever. So this is sort of a new model and process for the way that you need to deal with these problems. So first, you're going to need to collect data. Second, you're going to have to train what's called a model. And then finally, you can make predictions. So I'm just going to go through these steps now. So with the collection of data, within e-commerce, we're really talking about purchase data, product views, likes and ratings, and wish lists. It's really any data that connects a product to a user. So if it's data that indicates that someone is going to like or dislike something, even in a small way, that could be considered useful for figuring these things out. So you need to pay attention to those kind of connections. Okay, so I just want to take a little sidestep for a moment. Has anyone heard of Maslow's hierarchy of needs? Okay, cool. So you all know that each one of these things has to be fulfilled in order to get to the next level. So in order to feel love, you need to feel safety from a human standpoint. But the thing is that data has human needs too. So let's take a look at this. So if data was a person, data would like to be collected, and then it wants to be stored, then it wants to be analyzed, then it wants to make predictions, and then finally the best thing you can do for data is actually make decisions based off those predictions. So this is the kind of framework that you need in order to optimize and think about the way that your data funnel is happening here. Because I imagine that most people here are probably maybe getting to analysis, perhaps, so if you're doing some reporting, but it's about taking it right to the top. So this is a quick example of how this equation starts to change. So now if we're to implement the related products again, what we're doing is calling out to an API every time someone orders something. We're passing over a user ID and the product IDs that have been purchased. And just note that this is all metadata. We're not actually sending the full order data. We're just interested in the connections between users and products again. And then, of course, in your products controller now, every time someone is viewing something, just log the fact that user X has viewed product Y. And in this case, you'd want to make sure that these calls are asynchronous and fast. Okay, so that predictive API that we're calling, it's essentially ingesting that data. It's training a model at this point, and it's exposing some predictions back to you after that stage. So let's talk about the training model part. Now, this is probably the hardest part for me to explain because it's quite technical, and there's a lot of different ways to solve this sort of problem. So what I'm going to do is go through a very common example that's in e-commerce, and that's an approach called collaborative filtering. So this is how collaborative filtering works. So imagine that you have these different people around the outside and the colors, and imagine that you're a online store that is selling classes for different things. So we're selling a skateboard class, a surfing class, a horse riding class, and a cross-country skiing class. And of course, each of these particular people have ordered different combinations of these items. Some haven't ordered any at all. And let's just say, for example, that the purple man is currently on the website, and we're wondering, should we recommend horse riding to him? So what we do is we wrap that diagram up, that sort of network diagram, into a table. And every time that someone is someone has ordered something in this case, we're just going to put a tick for each of those things. And so we can see at the bottom left there, you've got purple man, and we're kind of wondering, will they be interested in horse riding? So what you do to figure this out and how the algorithm works is that you look at users that are similar to this user, that have a similar purchase history. And in this case, the first two people have both indeed purchased skateboarding and cross-country skiing as well. And so these people are probably quite a good guide for figuring out if this other person is interested in horse riding or not. And it appears that no, those other two people have not actually purchased horse riding. So the best prediction you could make is that this person probably is not actually interested in horse riding. So imagine what I just showed you now, except there could be 10,000 products across the top, and there could be 100,000 users on coming down the side. And each of these is not just a tick or a blank. It could be varying levels of weighting. So maybe if someone viewed something, you kind of treat that as like a 0.1 value, and maybe if they ordered something, that's quite a strong indication that they're interested in that. So call that 1.0. Maybe if they ordered it twice, then it's a 1.5 value. So these are all the weightings going on to try and determine this problem, but hopefully that gives you a good understanding of sort of at a high level how this works. So now when we go to make predictions, our method for getting products is quite simple. We just make a call out to a predictive API. We give it a user ID and the product ID that they're looking at, and we ask for 3 related products in advance. So my point is that machine learning is really greater than explicit programming. It's learning all the nuances of who's buying what and why, and automatically kind of updating those based on all that data. And you're not having to implement these explicit rules and theorize about these things. You just treat it as more of a mathematical problem. Okay, so you have to really apply this sort of machine learning mindset to e-commerce. And in order to do that, you have to think differently. You have to think about the 3 steps that are outlined around collecting data, building a model, and making predictions. That's sort of the new language that you need to use in order to do to think in this way. And really, if you're showing, this is the way that I look at it, is if you're showing the same information to many customers, then you're probably doing it wrong, or at least you're probably you have an opportunity open there that you could show people different things and more personalized things based off data. So, it might be the pricing or the categories and the way that you're showing categories or taxons and the way that the names on those and how they're filed together, or search results and the way that they're filed, or discounts you're offering. There's so many things you can do, and this is what I look for when you look at the things that you're showing to your customer. So now I want to talk about a real-world example. A client of ours, United Cellars. So they are a wine website, an online retailer in New Zealand and Australia. And we set out with the goal to increase their revenue. And we thought that product recommendations would be a really good way to do this. And in terms of implementation, we thought that predictive APIs, given that this is a consulting gig, that we need to be very productive and be able to build these features out quickly. So we use that as an implementation. So we had 16,000 product views in terms of data, 60,000 orders, and 3,000 product ratings. And so this is, it's only 79,000 rows of data. And where I live in the Bay Area, this is, people are always talking about millions, tens of millions, hundreds of millions of rows of data. And this is definitely not this. We're talking about tens of thousands of lines of data, rows of data. And, I just wanted to sort of state this because it means that if you're, have a smaller store, you just need to start collecting this data, knowing that you're trying to build up, and also that the quality of the data is key. So if you have really clear intentions about what you're trying to achieve, you can increase the quality and therefore the effectiveness of your data, and you don't need as much to achieve the same thing. So we realized when we were building this that, if I think about this room right now, the taste preferences in wine probably vastly different, depending on your background, what you like, and how much wine you've had potentially. This just naturally has a like this store had 10,000 wines. So if I think about everyone here and then trying to match you all to one of the 10,000 wines that they have, it's just an incredibly difficult problem. I don't think any one individual could do a very good job of that. So it just seemed like a really good fit, just because of how wine works and the fact that we have this range in tastes. So we decided to implement two things. We decided to implement personalized product recommendations, which is within the context of the entire store, which products are the products that are most relevant to this person. And the second thing was the similar products. So this is not in the context of the entire store. This is in the context of exactly what I'm looking at right now. So if I'm looking at product X, which products are similar to this product based on everything we know about the way people have been ordering it. And so that's going to change between pages when I'm looking at different types of wine. So we set up an A/B test to see how effective could this stuff be. And we showed 50% of the users the original site and 50% with the recommendations in place. And so this is what it looked like when we put it live. So across the left-hand side, you have recommended for you, which is those store-wide recommendations. And then across the bottom, we've got more red wine to consider, which is based on the context. It's a similar product recommendation based on the context of the very specific wine that we're looking at right now. Okay, so we put this live and we made one very big mistake, and that is that we were starting to recommend products that were out of stock. And so, those products were the best recommendation, the most tied to that user, and they were the best suggestion. But if you can't buy them, then why recommend them? So you need to filter your results, and at the end. And so really, I would extend that beyond just out of stock, but really anything that you can see that is lessening the relevance of those recommendations. So another thing that we noticed is that people, particularly with wine, tend to like red wine or white wine. We were able to see that with the existing orders. We could see that people would commonly buy these things together, and there wasn't too many people that would buy like even amounts of the two. So what I would suggest to you is just understand and think about the purchasing decisions that people make on the stores that you manage, and how do they shop, and that might give you some insight into how you might present this to the users. Okay, so we got some results back, and we got a 45% longer average session time, 22% increase in conversion rate, and 37% increase in average order size. And this resulted in a 71% increase in revenue. And this is because we both increased the conversion rate, but then they were also buying more. So it's those two things combined gave us a fantastic result that was really beyond our expectations. Okay, so now I just want to sort of rally the troops a little bit. Why is now a good time? If you're not doing this sort of stuff right now, now is a really good time to get started. The reason for that is that the hardware costs are falling a lot, and to run this stuff and to be cost effective, it's very computationally expensive, especially if you have a lot of data. So that's one significant factor. There are also a lot of advancements. There's a lot of focus in the academic fields around making everything more efficient, more effective, lowering the error rate and the accuracy, and also the hardware costs and advancements kind of tie together, because the libraries that are being built are becoming more tightly coupled with the hardware, so that we can combine those two things to be even more powerful and more efficient. So for example, swapping to GPUs, using GPUs instead of CPUs to do this processing is one implementation kind of trick that people have been using. And there's just significant investment. I mean, if you have looked at any tech news ever in the last little while, there's so much investment in this space. There's a lot of promise and a lot of hype too, so be careful of that. But just to give you an example, here is a graph from Y Combinator, which you probably all know what Y Combinator is, but to be very quick, it's a company that invests in a lot of startups, and there's application rounds where people submit their applicants to get invested in, and they get something like 2,000 applicants each time. And so they decided to actually go ahead and graph some of the mentions of words in their applications and graph that over time. And you can see that there's clearly a lot of startup people are really getting involved in AI, and they even said that this was kind of an underestimation, actually, of what's going on. Okay, so we've been running predictive APIs in production, and so I just wanted to give a couple of tips. So you have to be careful about monitoring performance. All of the benefits of machine learning can be entirely reversed if you just slowed the application down while you're doing it. So you have to be very, very careful about the speed in which you log the data, and then you do all the processing externally from the main app. So yeah, and then real-time, people talk about real-time predictions quite often, and I think that it's kind of overrated. Most of the time you don't actually need real-time predictions at all. If you have like 100,000 orders and you're doing product recommendations and a new order just came in, the chances of that new order like significantly impacting what you're showing to users right now is really low. So yeah, I would actually encourage, in order to get the best performance, that you cache everything instead and only update every time period. So for example, Netflix only updates their model for what they're showing you every day. So that just gives you something to anchor off. I'm sorry, this is a very small picture, but I just wanted to mention this incredible machine learning canvas. So the thing is that you need to be really clear about what you're trying to do and how you're trying to solve the problem of, and who's going to see what, where, and how is it going to work, and what data is going to be needed to calculate all that. And so this machine learning canvas by Louis, it helps you kind of scope out the problem and understand actually how all the bits and pieces come together to make sure that you have the full flow there. So it's really a nice way to better approach a project like this. Okay, so some conclusions. Machine learning is greater and more powerful, in my opinion, than explicit programming. It allows us to automatically adapt and automatically take in all of the data and react to that and show a very personalized experience. Predictive APIs are great. They allow us to encapsulate complexities of running machine learning in production, and allows us to treat it like a regular API that we would deal with, and start to incorporate these features in production more easily. Small data can be enough. You saw in the United Sellers example that I had relatively small data, but I would just argue that quality is key. So just be clear about what you're trying to achieve, and make sure that you have good quality data. And finally, machine learning is just highly effective in e-commerce. In the real retail space, it's not like the moment I step into a physical store, can it just automatically arrange all the products in a store and just instantly know everything I want and sort it by how I would like it. So we have a real opportunity to be able to, we're just incredibly lucky to be able to collect all the data that we can collect and customize everything that we're showing to each individual. And that would be very, very obvious in the real world. But we have a very unique opportunity to be able to do this because of the way that people interact with e-commerce. And also it just makes the customer's experience more personalized. It's kind of a win-win. It makes these stores more effective, but also more useful and helpful to the end customer, and they are less frustrated because they can get what they want more quickly. Cool, so the slides for this presentation are going to be up at resolve.digital. You can follow me on D_Jones if you like, and thank you very much.
How many iterations did your United Sellers model go through for you to reach 71% revenue?
I think we changed it about 3 times. So not many, actually, yeah.
What are the kind of levers that you're pulling when you're training the model like this? We talked about weighted attributes and those things. Could you speak a little bit more to that? Because it seems that training the model is the secret sauce.
Right. So we use a system called Prediction.io, which is a platform that provides a way to basically take your data in and then evaluate the effectiveness of different algorithms, and then there would be a process that would allow you to mathematically calculate like how well does this algorithm fit your data. So that's what we used for that stuff. Does that answer your question?
Sure.
Okay. Any other questions? Yep, down the back. Yep. That's a good question. I would probably just use like metrics and alerts on those metrics to try and react to, because I guess that could be caused by any particular system, not necessarily machine learning, but any kind of problem. So something like that, I would probably deal with it that way. Yep. Any other questions? Yep.
How about anonymous users?
Anonymous users. So Yes, we did actually. I had a slide in there. I took it out actually about this. So we did some cookie tracking for anonymous users, and if they logged in later, then we would actually connect that data together. So that allowed us to gain a better picture of what's going on, even if they hadn't logged in at that point, because if they go through all the browsing, they're probably anonymous at this point because they've come off, I don't know, Google or something like that, and they may not have even heard of the business. And then later on, if they go ahead and purchase something, that's when they're probably going to need to get an account, or they have a high chance of having an account, and we can connect that all together. Yep.
Yeah, a great presentation.
Thank you.
Thanks,
Brian.
I thought the results were really interesting. So you said 71% revenues jumped after you launched the related product. Was it after launching related products or launching related products with the predictive APIs?
So we didn't have any related products before then.
All right.
Yep. Cool.
Any idea what the impact of the predictive APIs would have, like if you had to take a guess on, like, I imagine introducing related products would have had some sort of increase.
Yeah, I've had this question before. So the way I'm going to answer this is sort of we could have been like super strict about measuring exactly the predictive gains, as opposed to the fact that you're just showing more products on the screen. And so obviously the way that you would do that is probably just like randomize for half, just give them random products, and the other half show them that. But that would have required that we kind of this data is more for that would have been for more our gain rather than trying to get the feature to the client.
Right.
So it would have been like, well, we have to use your time to be more meticulous about testing this stuff. So yeah, I don't fully know. I assume it would be quite a lot. At least the fact that it jumped that much just tells me a lot.
Sure.
If it was lower, then I'd probably be a little bit more curious about that sort of thing.
Yeah, and I think we can all benchmark it against related products, right? So it'd be interesting to sort of say, okay, we've seen some lift by doing related products. I'm very curious about doing something with these, with some sort of machine learning for better prediction.
Yeah.
Cool.
Yep.
Do you know if there's any CELLARS integration or any plan?
Yeah.
Predict.io?
So we do have some stuff that we were using internally. So yeah, there's no connection at the moment between that. But we do have some stuff internally for this. Maybe in the future we could make that a bit more generic. We'll see. Yeah, maybe if we implemented it in more stores and started to get something that was more generic, then it would probably make sense to do that. Yeah. Any other questions? Okay, cool. Thank you.